Welcome to Module 1 of CCNA, Introduction to Networks. This is our on-ramp for the whole course, so keep it conversational today. No deep technical detail yet. Tell them the goal by the end of this module. Understand why networks matter, and what the basic building blocks are. Mention Packet Tracer now if they have not installed it yet, since we will start using it in a couple of modules. One objective drives this whole module. Explain the advances in modern network technologies. Read it out loud, then tell them not to stress about it. This module is the big picture tour before we get into addressing, cabling, and configuration later. Remind them to grab Packet Tracer from the Narrated resource link before next class if they have not already. Start with the human angle, not the technical one. Ask the class, what would your day look like without internet access for 24 hours? Let a few answer. That is the point of this slide. Communication is close to a basic human need, and networks are what make instant global communication possible. This sets up the rest of 1.1. Build on the last slide. Networks remove boundaries, national borders, distance, physical limitations. Give a concrete example. A small business in Kinder, Louisiana can sell to a customer in Japan today, something that was unthinkable a generation ago. Global communities exist now, independent of location or time zone. That is the theme to underline here. The cloud slide is a good place to get students talking. Ask who has used Google Drive, iCloud, or Dropbox today without thinking about it. That is the point. Cloud access ice anywhere, anytime, any device, and it has become invisible infrastructure. We will come back to cloud computing in more depth in section 1.7. This is our first real technical building block, so slow down here. A host is any device that participates directly in network communication. Clients request, servers provide. Walk through the client-server diagram left to right. Then hit the table. Email, web, and file servers are the three types they need to recognize by name for the quiz. Contrast this directly with the last slide. In P2P, there is no dedicated server. Every device can act as both client and server. Ask the class, what is a real-world example? Home file sharing, or older tools like BitTorrent both work. Walk the advantages and disadvantages columns, and emphasize not scalable. That word will come back in section 1.6. End devices are where a message starts or ends. The network exists to move data between them. Go around the icon row. Computers, laptops, mobile devices, IP phones, printers. Ask students to name an end device in the room right now. This is an easy one, but it sets vocabulary we will build on immediately in the next slide. Now contrast end devices with intermediary devices. These do not originate or receive the message, they move it along the path. Switches connect devices within a LAN. Routers connect networks together. Wireless access points extend access. Firewalls filter traffic for security. Have them picture the school network. Which of these have they probably seen in a wiring closet? 3 media types carry the signal: copper, fiber, and wireless. Keep this at a conceptual level for now. We will get into cabling standards and connector types in a later module. For today, they just need to know copper carries electrical impulses, fiber carries light pulses, and wireless carries electromagnetic waves with no physical cable at all. This slide is really a vocabulary and symbol recognition slide. These icons, end device, switch, router, wireless router, cloud, are what they will see over and over in every topology diagram for the rest of the course, including in Packet Tracer. Worth having them sketch a couple of these symbols by hand to build recognition. Physical versus logical topology is a distinction that trips students up, so use the 2-column layout deliberately. Physical topology answers, where is the cable run, and where does the box sit? Logical topology answers, how does the data actually flow, and what are the addresses? A good line. Physical is what an installer cares about. Logical is what a network engineer troubleshooting an outage cares about. LAN and WAN is a foundational pair of terms they will use constantly. LAN, small geographic area, one organization, high speed. WAN, large geographic area, usually a service provider involved, slower links connecting LANs together. Ask, is our campus network a LAN or a WAN? Then ask, what connects our campus to the outside internet? 3 related but distinct terms here: internet, intranet, extranet. The internet is the global, unowned network of networks. An intranet is private, internal only. An extranet opens up controlled access to outside partners or suppliers. A good example for extranet: a supplier portal a vendor logs into to check inventory levels with a client company. This is a practical, everyday slide. Ask the class what type of internet connection they have at home. You will get a mix of cable and DSL, maybe some cellular hotspot users. Cover cable, DSL, cellular, satellite, and dial-up, and make sure they understand DSL's asymmetrical nature. Download faster than upload, since that comes up again later in the course. Now shift from home users to businesses. Businesses need higher, often symmetric, bandwidth and managed services. Cover the 3 types: dedicated leased lines, Metro Ethernet, and business DSL like SDSL. Point out the difference between consumer DSL from the last slide and business SDSL here. Symmetric speeds matter for businesses running their own servers. This is a good visual to slow down on. 30 years ago, data, voice, and video ran on 3 completely separate networks, each with its own cabling and rules. Today they all converge onto one infrastructure. Ask, why would a business want to converge these networks instead of keeping them separate? Answer, lower cost, less complexity, one set of rules to manage. This slide previews the 4 requirements we are about to spend a full slide on each: fault tolerance, scalability, quality of service, and security. Read the definition of network architecture first, then preview each icon briefly. Do not go deep yet, that is what the next 4 slides are for. Fault tolerance is about surviving failure gracefully. The key word is redundancy, multiple paths between source and destination. Walk through the diagram. If one path fails, traffic reroutes automatically, and the user often never notices. Mention packet switching briefly. A message gets broken into packets that can each take a different path to the same destination. Scalability is about growth without breaking things. A scalable network can add new users or even whole new networks without degrading performance for people already on it. Ask, why does following standards and protocols matter here? Because it lets hardware and software vendors build compatible products without having to invent new rules for every network. QoS is where bandwidth management gets real. Congestion happens when demand exceeds available bandwidth. Walk through the example on the slide. Voice and video need priority, because delay is very noticeable to a human ear or eye, while a web page loading a half-second slower is barely noticed. The type of traffic matters, not the content of it. Security closes out our 4 requirements, and it is really 2 categories: infrastructure security, physical devices and management access, and information security, the data itself, protected through confidentiality, integrity, and availability. This is a preview. Section 1.8 later in the module goes much deeper into specific threats and solutions. We shift gears into current trends now. Preview all 4 quickly: BYOD, online collaboration, video communications, and cloud computing. These are not separate ideas. They all feed into each other. A student on their own laptop, collaborating on a shared doc, video calling a teammate, all stored in the cloud, is living all 4 trends at once. BYOD, bring your own device. Ask how many students are using a personal phone or laptop on the school network right now. That is BYOD in action. The tagline to remember: any device, any content, anyway. Mention briefly that this creates new security considerations for IT departments, which we will touch on again in the security section. Collaboration tools like Cisco WebEx let teams work together in real time, regardless of location. Ask, what collaboration tools do they already use for group projects? Google Docs, Teams, Discord. All of these exist because networks make instant, shared collaboration possible. This ties directly back to the Networks Connect Us' theme from the start of the module. Video communications ties into QoS from section 1.6. Remind them of that connection explicitly. Video calls demand real-time bandwidth and low delay, which is exactly why QoS policies exist. Mention that video is used for more than meetings now. Entertainment, telehealth, remote learning, all riding on the same converged network infrastructure. Cloud computing gets its own dedicated slide, because it is huge in the industry right now. Walk through all 4 cloud types: public, private, hybrid, community, with an example of each if you have time. A hospital network needing HIPAA compliance is a good example of when a community or private cloud makes more sense than public. This is a good slide to pause on since security threats show up constantly in the news. Walk both columns together rather than reading straight down one side. For each threat, ask if they can guess which solution defends against it. Emphasize the closing line. A layered security approach, not any single tool, is what actually protects a network. Now we turn toward their own path forward. No prerequisites to start. That is worth repeating for students who feel behind. Walk through the CCNA exam scope, then mention specialist and DevNet paths exist beyond just CCNA if they want to specialize later in security, wireless, or software development. Practical, career-focused slide. Spend real time here. Show them the Talent Bridge matching engine on netacad.com if you have time to pull it up live. Remind them that searching Cisco CCNA directly on general job boards works too, and that this certification is something employers actively search for by name. Close the module by walking each bullet point as a recap, not by reading it verbatim. Ask the class to fill in the detail for each one before you reveal it, if time allows. This module was the foundation. Starting next module, we get into the addressing and protocols that make all of this actually work.